All right, guys, if you will turn in your semester exam review, please, to the very last page. Okay, we have 2 sections left, and so we're gonna just knock both of them out in this video. So we're gonna start with graphing trig functions, then we're gonna switch to graphing circles. Okay, so out of the first 2 examples, I'm gonna go ahead and do number 25, but before I do that, just on a sheet of scratch paper, I'm gonna remind you what each of the numbers does. So if you have y equals trig of, let's see, a, b, beta minus c plus d. Okay, each one of the numbers in those positions does something different. So first, let's talk about the number with theta is going to shift your graph left or right. That is called the phase shift. For all other functions, this is just called the horizontal shift. But for sine, cosine, tangent, all of those trig functions, it has a special name because they're like wave graphs, basically. Okay, the D back here is going to shift your graph up or down. Okay, and it is called the vertical shift. The number at the front here is your vertical stretch or compression. And it is going to determine the amplitude of your sine or cosine graph. Okay, the amplitude of your sine or cosine graph. Okay, then the last number is going to be the B, which is usually between the parentheses. And that number is going to affect the horizontal stretch or compression. Okay. Now, what you're going to see is that out of all 4 of those, 2 of those numbers are going to have the reverse effect of what you would think that number does. And that is going to be the horizontal stretch or compression, or the B, and then the C. Okay, let's talk about what I mean by that. Let's take a look at number 25. Okay, so first thing I notice is that I have a -10 in my parentheses. So remember what I said on my sticky note here, that this number C is going to have the reverse effect. So if they put a -10, that means that I really want to shift my graph to the right 10 units. Or 10 degrees. Okay, the next number that I'm looking for my vertical shift is going to be the D in this equation. Okay, but that D can be added at the end, or you'll see in number 25, it can also be added at the beginning. So if I put my 2 in the front, or if I put my +2 in the back, okay, either way, that is going to shift my graph up 2 units. Okay, so if I were to sketch a graph of this, okay, I would go to the right 10. So instead of starting at 0 degrees, I'd come over here. Let's say this is 10 degrees. And then I would want to go up 2. So that would put the new center of my sinusoidal graph, which is like the fancy name for the wave shape. Okay, that would be my new center. Okay, then my period is how long it takes to go through one full cycle. Okay, that is going to be determined by my horizontal stretch or compression number, okay, which is my B here. In this case, I see that I have a 1/2 in that position, which means divide by 2. But remember that because it has the reverse effect, I'm actually going to take my 360 degrees and I'm going to multiply it by 2. So if they tell me to cut it in half, really, I'm going to times it by 2 because of those parentheses. So 360 times by 2 is going to give me 720 degrees for my period. Now, if you want to go ahead and make a note to yourself, that means that this is a horizontal stretch. And the reason it's a horizontal stretch is because 720 is a longer period than the normal period, which is 360. So if I start at 10 degrees, that means that the very end of my graph should happen 720 degrees later, which means it would be at 7:30. Okay, then from there, there is one thing that is missing on here, but that really, it probably should ask you to find, and that is your amplitude or your vertical stretch or compression. So I'm going to add that down here. Okay, my vertical stretch or compression is determined by the number directly in front of the sine or the cosine. So I see here that I have a 3 in the front. So that 3 means that this is going to be stretched, and my amplitude is going to be 3. So here's what that means. My wave should go up 3 units and then down 3 units. So if I start here at 2 and I count up 3, 1, 2, 3, that means the top of my wave should be at 5. And then if I go back to the center and I count down 1, 2, 3, the lowest part of my wave should hit at -1. Okay. Then you should have learned the sine and cosine shapes. The cosine graph starts at the top of the wave, and then it's going to go down and then back up. Versus your sine graph is going to start at the center and go up the wave, down the wave, and then back to center. Okay. Now, what I will say, especially for my students, for Miss Joyner's kids, y'all learned that when I was on maternity leave. So we took the actual graphs off of this semester exam. The way that your questions for all of y'all are going to be worded is going to be just like number 26. So I don't want you to feel overwhelmed with this graph. You don't have to be able to do that. You just have to answer a question. Very, very similar to this. The other thing I want to point out is that your standard period is 360 degrees. So if I'm looking at number 26 here, I see that I have a +4 on the inside. Remember, that means that I want to go left pi over 4. So it could be A or B. I don't want C because it says right pi fourths. That's wrong. And right 2 units. That's wrong. Okay, then I notice here that I want to go down 2 or down 4. But I know that my down 2 comes from that -2 at the back. So at this point, we pretty much know it's A. Okay, then it says that my amplitude is 4. Remember, that's how tall the wave is in the front. And then the last part of this says that the period is 2 pi. But remember, that's the same as 360. And so if you look at this equation compared to the equation before it, do you see how you don't have this middle number? What that means is that your period on number 26 is still going to be 360. So it would still be 360, which is the exact same as 2 pi, which is how it's written in number 26. Okay, but if you can do a question like that, you know enough to do what's on your exam. Okay, go ahead and turn to the last page. Last page is equations of circles. So I'm just going to do 2 of these. Let's work through letter C. So it says identify the center and the radius and then graph it. So for my center, I want to choose the opposite of the number with X and then the opposite of the number with Y. Now, I do want you to be careful that on letter C, do you notice that the X comes second and then the Y comes first? Okay, it doesn't matter what order they add them in. You just need to make sure that your X in your ordered pair comes first, your Y comes second. So for my X value, X is with a +4. That means I'm going to put a -4. And then Y is with a +1. So I'm going to place that with a -1. Okay, then we're just sketching a very basic graph here. I'm gonna go to the left 4 and down 1. 1, 2, 3, 4, down 1. There's my center. And then my radius needs to be the square root of what this number is on the other side of the equals. So if it's a 25, that means that r squared is 25. I'll need to take the square root on both sides to find my radius. So it's going to be 5. So then from there, like I said, this is a very basic graph. You would go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then once you hit your 5 points, your center and the 4 around, you can just do your best to connect your dots. Okay, it doesn't have to look great, but all that you need to know for your semester exam is the relationship between the graph and the equation. Last one we're going to do together is number 28. So first step is going to be to organize your x terms and your y terms together. So I have an x squared and a minus 4x. I'm going to leave a little blank for my complete the square. My y's, I have a y squared and a 6y. Leave my blank. And then for my plus 1, I notice that it is on the wrong side. So when I push that across, now it's a -1. Okay, from there, for complete the square, remember, you can only take half of the middle term. So if it's x squared minus 4x, I'm going to change that to an x minus 2 squared. And then I would think in my head about, okay, if it's x minus 2 squared, that's x minus 2 twice. So x times x gives me x squared, I have it. That'd be a -2x and a -2x, which gives me my -4. But -2 times -2 is a +4, and I don't have that, so I fill it in the blank. And if I add 4 on the left, I have to add 4 on the right. Okay, that process is called complete the square. So let's take a look at our y's. Y squared plus 6y, but I can only take half. So instead of doing 6, I can only take 3. And then I think to myself, y plus 3 squared is y plus 3 twice. Y times y is y squared. I already have that. Y times 3 is 3y. There's another 3y, that adds up to 6y. But my last 3 times 3 would have been a +9. So if I fill in the blank over here with the +9, I also have to add a 9 across to the other side. Then remember from there to finish out putting this in graphing form, you're just going to need to add those numbers up. So in my calculator, if I do -1 plus 4 plus 9, -1 plus 4 plus 9, I'm going to get 12 for that radius number. Okay. So here's my equation of my circle. And then I want to identify the same 2 things that I was finding on question 27. I'm going to want to be able to find the center and the radius. My center comes from the numbers with x and with y. If I see a -2 with x, I know my real center is a +2. My y is with a +3. That means that my real center will be at -3. Then you can come over here and do your little sketch. I want to go to the right 2, down 1, 2, 3. There's my center. And then remember that 12 is r squared. So if 12 is r squared, then I need to square root both sides to know what my radius is. And I wish that 12 were a perfect square root, but it's not. So let's find out exactly how big the square root of 12 is. It's about 3.46, or we'll put 3.5. So when I come over here to my graph, I'm going to go 3.5 this way. So 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. and then 1, 2, 3.5. And then once you get your 4 points around the circle, you can go ahead and try to connect your dots. Okay, it doesn't have to look perfect, just making sure that you understand the relationship between your graph and your equation. All right, this should be enough to help you through your review. If you need help, ask me please in class. I'd love to help. Y'all have a great day.